you. Then that is the concept of a tangent line. Let us go to the first example here. Now, in the first example, find an equation of the tangent line to the parabola here at the point 1, 1. Okay. If you don't remember, let us go through it together. First, in order to graph the line here, okay, the coordinate in 2D, there's a y-axis here, and another axis here is in the x-axis. Right. First, let us determine what is the parabola here. So in order to draw the curve of this, we will plug in the values of x and y. So for example, when x is equal to 0, right? What is the value of y of this curve? Very good. Thank you. So it's 0 right here, right? How about at x is equal to 1? Good. 1 square gives us y is equal to 1. When x is equal to 2? Louder, please. Very good. So 2 square gives us 4. And how about 3? Very good. Okay. So the first point here, when x is equal to 1, y is equal to 1. Let us just, here, this is 1, this is 2, this is 3, for example. Then the left side of the x-axis here will be the negative value, -2 and -3. The distance of the unit should be the same in one axis. And in another axis, it's up to you, but you can pick, here is 1 and here is 2. Okay, but make sure that the distance will be the same. Okay? From 0 to 1, 1 to 2, and etc. Now, when x is equal to 0, then y is equal to 0. It means the curve will go through this point. Another point, when x is equal to 1, y is equal to 1, it will go through this point, right? 3, 4 here. So when x is equal to 2, y is equal to 4, it goes through this point, right? We can do the same things with the negative value of these. And we will see that it will go through at x is equal to -1, y is equal to 1 as well. -2, it will go through this point. Okay. Then we connect these points. It will give us the curve of this equation. Yeah, it's not a good draw, but okay, we accept it, right? This is the line y is equal to x squared. Okay, then find the tangent line of this parabola at the point P, 1, 1. And where is the point P? Right here, right? Okay. P, 1, 1. Okay, very good. But how can we just imagine and guess, right? It touched this curve at only one point here. It should be somehow like this, okay? This is what we guess. But how can we do this mathematically? So what is it? In order to draw this linear line, which information do we need to know? Slope, thank you, very good. And good job, impressive. Many people knows that. And here, okay, look at this. This angle here, we call it a slope. Let us define it as M, right? Let's call it M, which is the slope. And the slope of a line here, what is it? It is the change in y direction, right? For example, from this point to this point, this is delta x here, right? Okay, and the slope, okay, it will tell us how stiff the line is. Okay, so now let's take a look at the okay, here, right? The slope. Suppose, yeah, you can take a look at the notes, or look at here. If we are given a point Q somewhere Q here, right? Q, the coordinate of Q we don't know. Let us call it x1, right? And Q belongs to this curve, and let us call it y1. Or let us call it xpq and yq, which is the x coordinate of the point Q and y coordinate of the Q point Q here. So according to this one, let us suppose if Q if xq is given at the position x is equal to 2, right? What is yq? Someone said it, right? Thank you. So we plug into the equation, it will be xq squared, which is 4, right? Very good. This point. So from the given point here, so if we connect this line, the line go through P and Q, if a line it cut the curve at 2 points, we call it a secant line. Okay, it cut at the point P and the point Q. So can we write down the equation of the line going through P and Q here? First, in order to draw that line, we should know the, what is it? Good job. The slope of this guy, right? Mm-hmm. Let us call the slope of the point the slope of the line PQ M PQ, right? According to the formula, it is the change in Y divided by the change in X here, right? The change in Y, it means the difference between the P and Q coordinate in the Y direction. What is the coordinate of Q in Y direction? 4, very good, 4. And how about the the y coordinate of this p? Very good. 4 minus 1. Good. How about the change in x? Yeah, the distance from the position of p to q, here it is 2 minus 1 here, right? Very good. And it will be, oh, sorry, 3 over 1, right? Okay, very good. Similarly, now take a look at the, before doing that, let us play with another example. Let us continue. If x cubed is 1.5, right? What is y cubed? What is it? 1.5 square, right? But in math, we prefer fraction to this decimal. 1.5 is 3 over 2, and they're all square. It would be 9. What is it? Yes, 9 over 4. That is the y coordinate of q in this case. So in this case, then what is the slope of PQ? Right, we use the same formula, the change in y over the change in x. And here it is, what is y cubed? Yes. Very good. Subtract 1. And here is 3 over 2, subtract 1, right? Okay. Oh, this is tricky. Can any of you help me with this fraction? Good job. Wow, impressed. So here, 9 over 4. But can you explain how you do it here? Yeah, 1 is 4 over 4, right? This is another way to write 1. And the same things here. Below that, it is 4. Three. How about this denominator? Yeah, smart choice. So 1, we can also write it as 2 over 2. Why do we do that? Perfect. We cannot subtract or add a fraction with a whole number. We can only do that if they have the same denominator. And we rewrite number 1 in this way. Then the numerator here, this guy, we have the same denominator as this guy. So we can do addition or subtraction. It means it here will be 5 over 4 in the numerator divided by, here will be, yes, 3 minus 2 will be 1. It will be 1/2. Okay, now how can we deal with this? Great. Remember, good job. So this guy, the numerator, we can write it this way. 5 over 4 divided by 1/2, right? And remember, division of a fraction, we can change it to multiplication by flipping this fraction here. So it means that it will be 5 over 4 multiplied 2 over 1. Okay. With multiplication, we can write it as the product of and the denominator. 4 we can write as 2 times 2, right? Good, smart. Then in the numerator and denominator, they both have number 2. Okay, what should we do? They will cancel out. Good job. This guy cancel with this guy, leave us 5/2. Okay, then this is the slope of the new position here. And imagine when the Q here come closer and closer to P, it will, the tangent line, the secant lines will approach this red line, the tangent line of this curve. Okay, is it too fast or too slow? We good? We're not talking about the derivative, but we will. But yeah. The tangent in general, we will study the limit. And yeah, we'll study it later. Yeah, but this is the very beginning, the idea. But I'm glad that many people of you know about this. Good. So in general, here. Now in general, if we're given xq, then we can compute yq, which is x squared of the given point x, right? In general, the slope of this guy m here will be this fraction, right? They're the same thing here. And when q come closer and closer to p, and mathematically we write it as the limit. Just a new concept, new idea, but it's not new for many of you. But then if okay, then if we're given a point and a slope, how can we write the linear line of that curve? Slope formula, and what is it? So remember, so in general, it is y, if we're given y0, given the point x0 and y0 here, and the slope, right? We have the formula that y minus y0 is equal to m times x minus x0, right? Or another way to memorize this, remember, it is simply m is equal to y minus y0 x minus x0. This is the definition of the slope, right? We just do it before that. Very good. So then, if we're given the point P here, 1, and yp is 1, then somehow we compute the limit of this fraction and is given to 2. You can check it by reducing, okay, we have done here. When q is equal to 2 and then q is equal to 1/2, if you can check q is 1.1, for example, and 1.01, you will see that the slope will approach to 2 here. Okay, and that is the slope of the tangent line when q comes closer to p here. Having the slope here and the given point, we can simply apply the formula. And then this equation, we call it the tangent line through this point. And it is the red line here, okay? we can see in the pictures. First one, when Q is far away from P, it would be at this second line. When Q comes closer, the second line will somehow approach closer to the purple line here. And when Q comes closer to P, it will be this line. Okay? It will approach the tangent line. And however, if Q pass P and go to the left-hand side, this line is no longer the tangent line in the middle, but it is a secant line because it cut the curve at 2 points. Okay? For example, this guy, and this guy. I think for the introduction for today is enough, right? But do you have any question? Give me some comments. What should I do to make it better? I'm sorry. We still have some time. Let us get to know each other a little more. Sorry. Can you help me calling the name of people here so that? So I have a roster here. Our friend will call your name, and if you hear your name, raise your hand. Okay. Margaret. I just call her name. That's fine. Thank you so much. Elijah. Colin. Blake. Where are you, Dennis? Thank you. Anthony. Evan. Joshua. Fred. Catherine. Rachel. Yes, thank you so much. I think we should leave the classroom. But one more thing, please. I'm sorry. We'll continue tomorrow. And please log into my office hour. We'll introduce each other, know each other more. If you log into my office hour, introduce yourself. I give you 3 credit points for the coming test. Okay? Thank you. Sure. Yeah.